Its global production has doubled about every decade. According to estimates, over 380 million tons of plastic is produced every year. It's no surprise then that the plastic industry is valued at over $600 billion. So how is it made? Crude oil, the primary raw material for plastic, is extracted through a process called drilling. It involves drilling a well bore into the Earth's crust to reach underground reservoirs that contain oil. The drilling process typically uses a drilling rig, which is equipped with specialized equipment to penetrate the ground. Once the wellbore reaches the reservoir, the pressure within the reservoir forces the crude oil to flow up to the wellbore. This initial flow is often aided by the natural reservoir pressure. But as the pressure decreases over time, other techniques like pumping or injecting gases and fluids may be used to enhance oil recovery. Once extracted, crude oil undergoes refining by heating it in a furnace to about 752 degrees Fahrenheit or 400 degrees Celsius. Vapors from the oil move into a fractioning column, a tall tower containing a series of chambers. The chambers are warmer at the bottom of the tower and cooler at the top. The various substances that make up petroleum rise through the chambers as gases until they reach the temperature at which they become liquids. Since each substance has a different boiling point, it liquefies in different chambers and can be separated and collected. Ethane and propane, the building blocks of plastic, have low boiling points and are collected as gases from the top of the tower. Ethane and propane fractions, now separated from the crude oil, are subjected to a process called cracking. Cracking breaks down the larger hydrocarbon molecules in these fractions into smaller, more valuable molecules like ethylene and propylene. These smaller molecules are the monomers used in plastic production. The cracked ethylene and propylene monomers are then collected and prepared for the polymerization process. Polymerization. Polymerization is the core process in plastic manufacturing. There are two main methods. Addition polymerization. Monomers like ethylene and propylene undergo addition polymerization. Catalysts and initiators are used to break the double bonds in the monomers and create polymer chains. Polyethylene, polypropylene, and polyvinyl chloride, PVC, are produced using this method. Condensation polymerization. Some plastics are formed through condensation polymerization, where two different monomers react, releasing a byproduct like water. Nylon and polyester are examples of plastics formed this way. After polymerization, the resulting plastic can be converted into standardized plastic pellets, also known as nurdles. This process involves extruding the plastic into strands, cutting those strands into pellets, and cooling and drying them to maintain their quality. The nurdles are then packaged and transported to plastic manufacturers, who use them as raw material for various plastic production processes. Once the plastic pellets are received, they are melted and shaped into various forms using techniques like injection molding, extrusion, and blow molding. These processes determine the final product's size, shape, and properties. After shaping, the plastic is cooled and solidified to retain its intended form and properties. Plastic properties can be enhanced by incorporating additives during or after polymerization. These additives impart color, UV resistance, flame retardancy, flexibility, and other desired characteristics. In addition to primary plastic production, nurdles can also be used in the recycling process. Recycled plastic materials can be pelletized to create recycled plastic pellets, which are then used to manufacture new plastic products with recycled content. Nurdles can spill at every stage of the plastic production process, from production sites, during transportation, and in the manufacturing stages. Factory spills and spills during transit are a result of limited awareness, careless handling, insecure storage, and inappropriate equipment. When nurdles spill onto the ground, wind and rain can wash them down storm drains or into waterways, from where they ultimately end up in the ocean. To prevent nurdle spillage and uphold responsible plastic manufacturing, a range of quality control procedures should be implemented. This involves establishing good manufacturing practices, GMP, tailored to plastic pellet production, utilizing proper handling and storage guidelines, ensuring robust pellet packaging, conducting regular quality assurance checks, and providing thorough employee training on spill prevention and response. Thinking of application, here's how plastic Coca-Cola bottles are made.
दोस्तों, प्लास्टिक एक पॉलीमर होता है जो कि पेट्रोलियम का ही प्रोडक्ट होता है। अब आप सोच रहे होंगे कि पेट्रोलियम क्या है। मैं आपको बता दूं कि पेट्रोलियम हम उस कच्चे तेल या क्रूड ऑयल को कहते हैं जिसे हम एक्सट्रैक्ट करके ज़मीन के अंदर से निकालते हैं, जिससे हमें डीजल, पेट्रोल जैसे और भी ईंधन प्राप्त होते हैं। क्रूड ऑयल को ज़मीन से निकालने के बाद उसका डिस्टिलेशन प्रोसेस होता है, जहां क्रूड ऑयल को अलग अलग टेम्परेचर में गर्म किया जाता है अलग अलग चीज़ों को पाने के लिए। और इसी पेट्रोलियम डिस्टिलेशन प्रोसेस में नेफ्ता भी मिलता है, जिससे प्लास्टिक बनाए जाते हैं। दोस्तों, नेफ्ता एक जटिल हाइड्रोकार्बन होता है जो कि कार्बन्स की लंबी लंबी और कॉम्प्लेक्स चेनों से मिलकर बना होता है। दोस्तों, नेफ्ता को सबसे पहले नेफ्ता क्रैकिंग सेंटर में भेजा जाता है, जहां पर नेफ्ता को कॉम्प्लेक्स से साधारण रूप में तोड़ा जाता है। और इसे तोड़ने के लिए सबसे पहले नेफ्ता की थर्मल क्रैकिंग प्रोसेस होती है। उसके बाद क्वेंचिंग प्रोसेस और कंप्रेशन प्रोसेस होती है। उसके बाद अंत में रिफाइनिंग प्रोसेस होता है। इस तरह से नेफ्ता क्रैकिंग से हमें कई तरह के प्लास्टिक प्राप्त होते हैं, जैसे कि इथेलिन, प्रोपिलीन, बुटाडाइन etc। इसके बाद जिस टाइप का हमें प्लास्टिक चाहिए होता है, उस हिसाब से विभिन्न गैसों, पदार्थों के साथ रिएक्शन कराए जाते हैं। रिएक्शन हो जाने के बाद गैस को एक चैम्बर में भेजा जाता है, जहां गैसों के छोटे छोटे मॉलिक्यूल्स यानी मोनोमर आपस में जुड़ करके एक लंबी चेन बना लेते हैं, जिसे हम पॉलीमर कहते हैं। और उस पॉलीमर को एक्सट्रूडर में डालकर पानी मिलाकर पॉलीमर पाउडर में बदल देते हैं। और पॉलीमर बनाने का यह प्रोसेस पॉलीमेराइजेशन कहलाता है। पॉलीमेराइजेशन में अलग अलग प्रकार के गैसों से अलग अलग प्रकार के पॉलीमर बनाए जाते हैं, जिसे हम प्लास्टिक कहते हैं। फॉर एग्जाम्पल पॉलीथीन, पॉलीकार्बोनेट etc। इस तरह से इस बनाए गए प्लास्टिक का यूज़ हम अलग अलग कामों के लिए करते हैं।
This program will explain the various types of processing machines used to make the wide range of plastic products in use throughout our lives. A good start is injection molding. Injection molding is used to make plastic parts using two-part molds that, when closed, are injected with melted plastic to form individual parts. Here's how it works. Material gravity flows into the injection machine's screw, where it is melted by the compressing motion of the screw and then injected into the mold to form the part or parts. The mold is quickly cooled, letting the parts solidify. The mold opens to release the parts, and the mold closes again to repeat the cycle over and over again. Molding cycles can last anywhere from 1 second for tiny parts made in tiny molding machines to minutes for large parts made in presses the size of a building. Extrusion processes use the same plastic melting operation as injection molding, but there is no mold, and the resin compressing screw rotates constantly, and product is created continuously. Extrusion uses a die, a hollow form that molten plastic is pushed through to create its specific shape and thickness. A water bath or spray chamber then cool the extruded shape and often provide pressure and/or vacuum controls to properly size the product as it passes through. Belts or cleated pullers apply smooth tension on the product and keep it moving in pace with the extruder. A cutter or saw create the final product length, or a winder creates spools of the final product. There are many variations to the extrusion process, but a mixture of extrusion and molding is found in the blow molding process, where plastic is continuously extruded into a tube shape and then clamped in a mold and blown into its shape with compressed air. It's a process that often operates in a shuttle movement with a set of molds. each mold takes a turn grabbing a section of extruded tube, called a parison, and shuttling it to one side to blow it into a bottle shape, letting it cool, and then releasing it to be filled with product or shipped. Each mold alternates with a second mold doing the same thing for maximum productivity. The same blow molding process can also utilize multiple extruders for what is called co-extrusion. Co-extrusion is used to create bottles made up of multiple layers, and each layer possesses special characteristics like suitability for food contact, an outside color for brand awareness, ultraviolet light protection for long shelf life of the product, a layer of regrind for economical reuse of scrap, and many times barrier and adhesive layers are included to separate and bond the layers for a tough, cohesive bottle. A high volume form of blow molding uses many molds mounted onto a continuously rotating wheel mechanism. The extruder creates a hollow tube, and as the wheel rotates, each of its molds will open, grab a parison from the extruder die, blow the parison into a bottle, allow it to cool, and then place it onto a conveyor, producing a continuous stream of finished bottles originating from that continuous flow of plastic from the extruder. These wheel machines can also produce co-extruded bottles containing layers designed to meet the needs of the product and to use reclaimed material for maximum economy and recycling benefits. The very popular sales of plastic bottles for carbonated beverages has created a unique process for blow molded bottles made specifically from polyethylene terephthalate, or PET. For PET blow molding, bottles are first created in a test tube shaped, injection molded preform, and then, in a separate operation, reheated and blown into their final shape. This two-stage process creates bottles that we, as consumers, know to be thin-walled, yet capable of containing gaseous carbonated beverages without losing pressure or exploding, even if they are dropped. In the blown film extrusion process, thin plastic material for products like garbage bags or the sheeting used in construction, industry, and packaging are produced. A very thin die opening, which is often fed by multiple extruders, faces upward in a round shape. A tall, thin, continuous bubble is produced vertically by this process, and it's cooled as it flows upward, typically 30 feet or more, where it is then folded and brought back down and placed onto rolls or converted into popular film products. And all these processes, from injection molding to film extrusion, rely on Conair products to support their productivity and efficiency.
So you threw your waste in a recycling can. Congratulations, you fulfilled your duty as a citizen. Or did you? It's easy to forget what actually happens to our waste, but there's a lot more to the recycling process than you may think. In fact, you'd be surprised to know that only a portion of the material is actually recycled. What happens to the rest of it? The recycling journey begins with the collection of recyclable materials. This can take place through various methods, such as curbside collection programs, drop-off centers, and commercial recycling services. To facilitate efficient sorting and processing, it's essential for consumers to separate recyclables, including plastics, paper, glass, and metals from non-recyclable waste. The collected material then arrives at a material recovery facility, MRF, also known as a recycling plant or recycling center. It's a crucial hub in the recycling process where recyclable materials are sorted, processed, and prepared for further recycling or manufacturing. These facilities can be anywhere from 7,000 to 8,000 square meters in size and sort 400 tons of waste every day. Here's what typically happens at an MRF. When recyclables arrive at the MRF, they are unloaded from collection trucks and brought to the facility's tipping floor. Here, workers or automated equipment may perform a quick initial inspection to remove any obvious non-recyclable items, such as large trash or hazardous materials. After the initial inspection, waste is pre-sorted. In this process, large or easily identifiable items that are not part of the recyclable stream, cardboard, large plastic items, are manually removed. After pre-sorting, MRFs employ a combination of manual labor and advanced sorting technologies to separate recyclables efficiently. Automated conveyor belts, screens, air classifiers, magnets, and optical sensors are some of the equipment used to sort materials based on their properties, such as size, weight, shape, and material type. These rotating cylindrical screens separate materials based on size. Smaller items fall through, while larger items continue down the conveyor. Powerful magnets are used to attract and separate ferrous metals containing iron, such as steel cans. These devices use sensors and cameras to identify and separate materials based on their optical properties, such as color and shape. They can sort plastics by resin type and colors. Air jets are used to separate lightweight materials, like paper and plastic, from heavier materials like glass and metal. Despite advanced technology, manual labor remains important in the sorting process. Workers stationed along the conveyor belts manually remove contaminants, as well as items that the automated systems may have missed. Manual sorting helps ensure higher quality recyclables. After sorting, the separated materials are compacted or baled. Baling involves compressing materials like paper, plastic, cardboard, and aluminum into large blocks or bales. This process makes the materials easier to handle, store, and transport. Bales of sorted recyclables are stored in the MRF until they're ready to be transported to manufacturers for further processing. Proper storage helps ensure that the quality of recyclable materials is maintained. Some non-recyclable or difficult-to-recycle items, known as residue, may still be present in the sorted materials. MRFs manage this residue, which may include items like plastic bags, food waste, and small non-recyclable pieces. Once baled and sorted, the recyclables are sold to manufacturers and processing facilities as raw materials. These materials will be used to produce new products, reducing the need for virgin resources. Many modern MRFs use data tracking and monitoring systems to measure efficiency, track contamination rates, and identify areas for improvement in the sorting and processing processes. This data-driven approach helps optimize operations and enhance recycling outcomes. Once sorted by the MRF, the materials are then transported to processing plants where they're subjected to specific processing methods based on their types. Each material type requires unique treatment to prepare it for reuse. A. Paper. Paper is often shredded and mixed with water to create a pulp. This pulp is then cleaned and refined, removing ink, adhesives, and other impurities. The resulting pulp can be used to produce new paper products. B. Plastics. Plastics are sorted by type and then undergo processes such as shredding, washing, and melting to create plastic pellets. These pellets serve as the raw material for manufacturing new plastic products. C. Glass. Glass is crushed into small pieces known as cullet. The cullet is melted down to produce new glass products, reducing the need for raw materials and energy compared to making glass from scratch. D. Metals. Metals like aluminum and steel are melted down to form ingots or sheets. The recycled metal can be used to manufacture a wide range of products, from cans to car parts. Processed materials are sent to manufacturers, who use them as inputs for creating new products. The use of recycled materials in manufacturing reduces the demand for virgin resources, conserving energy and reducing greenhouse gas emissions. The newly manufactured products are distributed to consumers through retail outlets. These products, made from recycled materials, offer the same quality and functionality as those made from virgin resources. By purchasing and using these products, consumers support the closed-loop recycling system and promote sustainable practices. Eventually, recycled products may reach the end of their useful life. At this point, some materials can be recycled again, continuing the cycle. For instance, aluminum can be recycled indefinitely without losing quality. Other materials might have limitations on the number of times they can be recycled due to degradation. Let's return to our initial question. Can all waste be recycled? If not, how much of it isn't recycled? Well, the answer is not all waste can be recycled due to technical, economic, or environmental constraints. As far as percentages go, 60% of the waste that ends up in a recyclable can is not recyclable. Here's what happens to it. A significant portion of non-recyclable waste ends up in landfills. Landfills are engineered sites designed to contain waste and minimize its impact on the environment. However, landfills can pose environmental risks, including groundwater contamination, production of greenhouse gases like methane, and the potential for long-term pollution. Some non-recyclable waste is incinerated in waste-to-energy facilities. Incineration involves burning waste to generate energy, typically in the form of heat or electricity. While this method can reduce the volume of waste and recover some energy, it may also release pollutants into the air and contribute to air quality concerns. To reduce the amount of waste sent to landfills and incinerators, waste reduction and minimization strategies are crucial. This includes practices such as source reduction, producing less waste to begin with, reusing items, and composting organic materials.